Faraday's law tells us that if you change the magnetic field going through a loop of wire, it will induce a voltage proportional to how quickly the magnetic field changes and the strength of the magnetic field change. So if I point a magnetic field directly into the loop, it creates a spike in the magnetic field. If I take this out, it creates a spike in the opposite direction because the magnetic field is changing in the opposite direction. Of course, the reverse happens if I reverse the polarity of this magnet. Now, using the same magnet, I'll slow down how quickly the magnetic field changes. Notice the spike in voltage is a lot less spiky. Instead, now I'll do it much faster. And I get much stronger peaks. Of course, relativity means I could move the wire instead of the magnet. We can also use Faraday's law to measure the magnetic field of the Earth. I've oriented this coil of wire here so that at some point on its spin, it ought to be perpendicular to Earth's magnetic field, which is pointing north and has some inclination. Since the Earth's magnetic field through here will be changing as it spins, the voltage will change commensurately, and it should look like a sine wave. By measuring the frequency and amplitude of that sine wave, we can calculate the magnetic field of the Earth. From our readout, we can see that the frequency is about 15 hertz. Just remember, these are all going to be in SI units. Our peak-to-peak voltage is 238 millivolts. So our amplitude is about 0.12 volts. Our Faraday's law equation is, if we approximate this as a sine wave, what we get is so solving for B, we get with A being the area of our loop and N being how many loops of wire there are. Now, since the signal is small, I had to send it through an amplifier in order to get a readout. So in the end, I'm also going to have to divide by the gain to get the actual voltage. Now, looking at our loop of wire, has an area of 127 times 10 to the minus 4th meters squared, and 84 turns. And the gain on my amplifier is 20. So if I put all of these into this equation here, we end up with a magnetic field of about 6 times 10 minus 5, and since we've been in SI units the whole time, Tesla. The accepted magnetic field in Los Angeles is actually 5 times 10 to the minus 5 Tesla. So we got awfully close just using this little motor apparatus.